Hi, good day to everyone. This is Lau from Group 7. So let's start the video with some news. And on the left, you can see there are two robbers break into two houses and causing about 36,000 ringgit loss to the family. And on the right news, you can see that the robbers break into the same house within 24 hours and causing about 86,000 ringgit loss to the family. So from these two accidents, the police reports that there is no surveillance system and also there's no police patrolling in the residential area, and this is why causing this kind of accident happens. And from our 1 hour research, we also found that the ratio for Malaysia police officer is not enough because the ratio is only 3.6 police officer to 1,000 Malaysia citizen. So which means we have not enough police officer to take care of all the citizens. And this is why we introduced this surveillance drone system. So by using this surveillance drone system, the first thing we can solve is we can reduce the workload of the security officers, where the security officer just control the drone to patrolling around. And also, unlike the traditional system, for using a surveillance drone system, it can cover a bigger coverage, and also it doesn't have any blind spot like CCTV. And using a surveillance drone system, you can track the theft until the police officer arrive to the theft and catch them. And lastly, the surveillance drone system, it can record it as a documentation for future evidence. Thank you.
Our objectives for this project are to develop a surveillance drone system using the Internet of Things for industrial security application. The next one is to integrate the surveillance drone system with mobile applications through IoT. And the final one is to remotely control the surveillance drone system based on IoT for industrial security application.
Today, I'm going to share about the methodology part in our project. In methodology part, we have experimental setup and project architecture. As for the product architecture, the surveillance drone is built out by using mechanical electronic system and software system. For the mechanical system, we use drone frame and motor, whereas for the electronic system, uses power module, communication and control module, sensor module and actuator, and user interface module. As for the software system, we use the embedded software and mobile app system. Lastly, for the product architecture, this is the flow diagram for the overall system of the drone, camera, and the app system.
To enable the camera on the Raspberry Pi, we need to use this command, which is the sudo raspi config, and enter. We choose the number 3, the interface options, and yes, at the first option there is the camera. To enable or disable the connection to the Raspberry Pi, we choose the first one, and yes, okay, and then we click finish. And the red light at the camera is a light up, which indicate the camera is enabled.
I will show you on how to calibrate the drone. The three main components to power up the drone is the gyro, the microcontroller, receiver, and transmitter, and also ESC and power motor, and also a lithium battery which can be rechargeable.
Motion iOS is a Linux distribution which turns the single-board computer into video surveillance system which supports all versions of Raspberry Pi. This is the app developed by Tan Yin Swan, where through this app, the user just need to add the IP address and the user can monitor the live streaming which is recorded by the surveillance drone.